Alright, next flipped lesson in our Common Core Algebra 1 class. So we are in Chapter 2 now, and the first section talking about writing equations for line. Today in the video, really what we're going to focus on is solving linear equations, completing a table, and using that to graph a line, and then identifying slope, x-intercept, and y-intercept, which none of that should be new to students this year. So first piece, in order to solve a linear equation, what you need to do is the inverse operation to isolate the variable. And what I mean by that is if we look at our example, we want to get rid of, or we want to solve for x. So remember, our answer should look something like x equals, and then this is going to be some number. So in order to do that, we need to isolate the variable, or get x by itself. We're going to do that by, since we have a minus 7, remember we have a left side and right side, we're going to add 7. Remember, anything we do to one side, we have to do to the other side, so I'm going to add 7 to the other side as well, which will make those cancel out, and I bring down my 2x, I bring down my equal sign, and 12 plus 7 is going to give us 19. And then finally, to get rid of that 2, since we're multiplying here, we're going to divide. Okay, and 19 divided by 2 is going to give us a decimal, and that's okay. We're going to end up with x equals 9.5. Okay, the other example we have here, and there are a couple different ways to solve this one. The way I'm going to show you how to solve it is with distribution. So we can't forget that when we have a 3 outside the parentheses here, it means we have to distribute it, which is multiplication again. So 3 times x is going to give us 3x, plus we also have to do 3 times 3, which is equal to 9. We're going to subtract 9 from both sides, and that'll end up with 3x, bring down the equal sign, 3. We divide both sides by 3, and so that's going to end up x equals 1, because 3 divided by 3 is 1. Also, the other thing I'll add is, remember, there's an easy way to check this. You would take that 9.5 and plug it back in. So 2 times 9.5 minus 7 would give us 12. And over here, if we plugged it in, 1 plus 3 would be 4. 3 times 4 would be 12. Okay, so those are 2 examples. Another 2 examples we have are ones like the first one here on the left side is variables on both sides. Remember, we can't have variables on both sides, so we need to get them both on the same side, which means I need to eliminate one from one side. I'm going to choose this one because it's a smaller value. And remember, anything I do to one side, I have to do to both sides. So I subtract 2x, those cancel out. 3x minus 2x over here is going to leave us with 1x. I can bring down my plus 8 equals, and we don't want just 12. We need to make sure we bring down that negative sign as well. Last step then would be to subtract 8 from both sides, and we end up with x equals a negative 20 in this case. And again, if you plug it back in, you'd end up with the same value on both sides. Okay, be careful with this next one now. It looks a lot like what we just saw, but here we don't have variables on both sides of the equal sign. We have variables on the same side. So what I need to do is combine my 5x with my 3x. So 5x, and that's a negative 3x, or 5x minus 3x, is going to give us 2x. I can bring down my plus 6, and that's going to equal 16. End up subtracting 6 from both sides next, and we get that 2x is equal to 10. Last step is to divide by 2, and so we see that x is equal to 5. Okay, so that would be our solving equations. That's our first topic. Our next topic is how to complete a table. So you're going to be given some problem situation like we have here. Johan walks at a speed of 4 miles per hour. And we need to identify our independent and dependent quantity. Now, if he's walking miles per hour, that tells us that we are talking about time, because we have hours here. And so my unit for time is going to be hours. And remember, time is almost always the independent quantity. And now think about this. The longer we walk, or the amount of time we walk, changes the distance that we walk as well. So the more we walk, the farther we go. And in this case, we are measuring in miles. So our expression, we want to start with a variable. For our independent quantity, we always just have a variable. Think of this just like the computer lab. And then since we walk 4 miles per hour, for every hour we walk, we're going to go 4 miles. And so that gives us 4x. So filling in this table, what we would get, 0.25 times 4, we're just going to multiply all of these by 4 to get over here. So we'd walk for 1 mile. 0.5 times 4 would give us 2 miles. 1 hour should give us 4 miles, which makes sense because it's 4 miles per hour. 1.2, then we'd plug that in, we'd get 5, and 1.5 we'd end up with 6. So once we have our expression, it's fairly easy to fill in our table. We just take these numbers and plug them in. 4 times 0.25, 4 times 0.5 times 1, whatever the numbers are in the table. And that's how we do a table. Now, we can use that table to draw a line. And you'll notice in our table, I'm going to, our independent quantity always goes along the bottom, so I'm going to label this as time, or in parentheses I'm going to write my unit for hours, and then up the side here we have distance, and I'm going to label that unit as miles. Okay, going back to look at the table again, I see my time goes from 0.25 up to 0.5, or 1.5. So the highest number I need to have on X is 1.5. Okay, and so I'm going to put in 1 for 1 and also 1 for 0.5. Okay, and looking back at the table one more time at our dependent quantity, you see we go 1, 2, 4, 5, 6. So I need to make sure that my left side goes all the way up to 6, and then I'm just going to put 5, 4, 3, 2, and 1. 2, 3, 4, 5. Okay. So at 0.25, we are at the point 1. So I'm looking at this as an ordered pair. 0.25, 1. I'm going to plot that one. 0.25 and 1. When we were at 0.5, we had 2. And then, let's see, we did 1 at 4. So at 1, we were up at 4. And then, whoops, wrong way. Let's see, 1.25 is 5 and 1.5 is 6. So I'm going to go 1.25 was 5 and 1.5 was 6. Okay, and you'll notice it's not perfect, but if I connect those points, I can draw a line that's going pretty much through all of them. Okay, so it's not perfect, but it's pretty close. So you'll see that's how we use the table to graph a line. Each one of these points was an ordered pair from the table. This was 0.25, 1. This was 0.5, 2. We had this one at 1, 4, 1.25, 5, and finally 1.5, 6. Okay, so we're using ordered pairs to graph points that we can then draw a line. Again, just like you do in the computer lab. Now, moving on from that, we're going to have from each line a slope, an x-intercept, and a y-intercept. Our slope is going to be our rate of change. Okay, in order to find a slope, what we're going to do is take the difference of the dependent quantity over the difference of the independent quantity. So you're going to want to keep this as a fraction. And then also this is going to be constant for linear equations, which is what we're going to be looking at mostly this chapter. Our x-intercept then, if you think about what this word means, intercept to cross the x. So it's the point, the coordinate pair, where we cross the x-axis, and then such the y-intercept is going to be the point where we cross the y-axis. Okay, moving on from there, then looking at our point, or at our line. If I look here at this point, I have 2, 0, and if I look at this point, I've got coordinates 4, 4. Okay, so to find my slope, remember your dependent quantity is always the second number, so I'm going to take the difference of my dependent quantity over the difference of my independent quantity. So 4 minus 4 is 4, over 4 minus 2 is 2, which is going to give us 2, or if we want to write it as a fraction, 2 over 1. Which makes sense because if you look at what we got here, we go up 4 units. And then we go to the right 4 units. Now we could have used this point down here. You'll notice the same idea. We go up 4 units and then we go right 2 units. So our x-intercept then, you'll notice, is right here, right where we cross the x-axis. So that is going to be at 2, 0. And our y-intercept right here, pay attention, our y-intercept always has to have 0 for x. And we're actually at negative 4, for y now. Okay, so you've seen most of this stuff in the computer lab already. Then our last piece is how to write a linear equation. So we're going to be looking for something of this form where m is the slope or the rate of change, and b is the y-intercept or also the initial value. So if we think back to that Johan problem that we were talking about, we had an expression for our dependent quantity was 4x. So our equation, once we have our expression, we can just say is f of x equals 4x. In this case, you could even think about your b, the y-intercept, as being 0, because when he starts walking, he hasn't gone at all, and then his rate of change is how much he walks per mile. So this is also your slope, which is 4. Okay, so that is it for this lesson. We will be spending more time identifying independent and dependent quantities. We'll spend a lot of time in class writing linear models and more particular equations, and then we'll graph and identify the important characteristics, meaning the slope, the x-intercept, and the y-intercepts.